In this video, we'll talk about how to graph a parabola in vertex form. So we say that a parabola is in vertex form if it has the following form: y equals a times x minus h squared plus k. So let's work through a couple examples. Let's say we have y is equal to negative 3 times x minus 2 squared minus 4. How can we graph this parabola? Well, the first thing that we want to do is we want to identify the vertex. So the vertex, we'll write v, has the following coordinates: h, comma k, where h is the value right here, and k is the value outside of the parentheses. So we can see that the vertex for this particular parabola is located at 2, negative 4. So we know the vertex, so let's go ahead and graph that. So 1, 2, 1, 2, 3, 4. So here's our vertex. We'll call that V. Now we just want to find two more points that we can add to this graph so that we can create our parabola, or we can graph our parabola. So the easiest way to do that is to find the y-intercept, because that's the point on the graph where x is equal to 0. So the way that we do that is we can plug in a 0 for x. So let's write y-intercept is equal to, we'll plug in a 0 for x into this equation and see what we get. So y is equal to negative 3, 0 minus 2 squared minus 4. So we get 0 minus 2, that's negative 2, squared is a positive 4. So we have negative 3 times 4, so that's negative 12. And then we have a minus 4 out here, so minus 4. So negative 12 minus 4 is negative 16. So our y-intercept will be 0, comma, negative 16. So to graph that on our plot, that will be all the way down here somewhere. So we'll say 0, negative 16. This is this point. So we can graph our left-hand side of the parabola. So notice that this parabola will open down. And that makes sense because the coefficient in front of this x minus h right here is negative. So whenever we have a negative coefficient, that's kind of a dead giveaway that the parabola will open down. So let's see what we did to go from the vertex to this y-intercept. It looks like we had to go to the left 2. Because remember, the vertex is located at 2, negative 4. So to get to the y-intercept, we had to go to the left 2 to get to an x-coordinate of 0. So to find the point that is symmetrical on this right-hand side, because remember, a parabola is symmetrical about the vertex, this point all the way down here will have the same y value as this point, so negative 16, but the x value will have to go 2 in this direction from the vertex. So we'll have to add 2 to our x value of the vertex. So 2 plus 2 is 4. So this point here will be 4, negative 16. And now that we know that point, we can draw the right-hand side of the parabola and make sure that it goes through that point. So that's our parabola. That's how we can graph it when we're just given this equation in vertex form. Okay, let's try one more example. Let's say we're given this formula for a parabola in vertex form. How can we figure out how to graph this? Well, once again, we first want to find the vertex. And remember, the vertex has coordinates h, comma k. So for this example, our h will be a negative 4, and our k will be a positive 3. So our vertex is located at the points negative 4, 3. So if we create a graph to visualize this, we have 1, 2, 3, 4, 1, 2, 3. Here's our vertex right here. Now remember, we just need to find two more points to create a graph of this parabola. So the easiest way to do that is find our y-intercept, because that's the point where x is equal to 0. So we can plug in an x for this equation and see what we get for y. So we'll say y-intercept. Y is equal to 1/4 0 plus 4 squared plus 3. So we get 0 plus 4 is 4. 4 squared is 16. So 16 times 1/4, or 16 divided by 4, That's just 4. And then we have a plus 3 out here. So that is equal to 7. So our y-intercept has the following coordinates: 0, 7. So if we were to plot that on here, we have 0, 1, 2, 3, 4, 5, 6, 7. Here's 0, 7. So we know our parabola opens up in this direction and it goes through the point 0, 7. Now to find the point over here on the left-hand side, we just need to ask ourselves, to go from the vertex to the y-intercept, what did we have to do? Well, remember the vertex is -4, 3. So to get to this y-intercept, we had to go 4 in this direction. So to find the point that is symmetrical on this left-hand side, we need to go 4 in this direction. So a -4 minus 4, so that will put us at -8. We'll say 5, 6, 7, 8. And we know that the y value for this point over here must have the same y value as the x-intercept. So this point will be -8, 7, because that's the point that is symmetrical to 0, 7. So we can go ahead and draw this left-hand side of the parabola. And it goes through the point -8, 7. So that's how we can draw this parabola using just this equation in vertex form.